research. I have three ongoing research projects, which I expect to continue in my career. And these are my own ideas as principal investigator. And what's really nice about these projects is that, well, first they're really exciting, but also because I've been working on these for a while. It's one of those things that when I start doing research, I'll get results right away, and there won't be downtime until I stumble upon what I want to do for my research. I've recently I've been working with about 5 students, undergraduate students per semester on these research projects. So I really understand how to work with students and to actually get research results from them. So I have 3 research projects. The first research project is a functionalization of carbon nanotubes research project. There are actually 2 parts to this research project. There is the surfactant functionalization project, and there is the chlorophyll or DNA functionalization research project as well. So carbon nanotubes are these, it's a new form of carbon. If you think about it, diamond and graphite has been known for a really long time. And then in the last 10 years or so, carbon nanotubes have been discovered and have become very important, and people are doing a lot of work with it. So carbon nanotubes are this new form of carbon, and it's very strong, and it's kind of electrically conducting. So there's a semiconducting carbon nanotubes, and there are conducting carbon nanotubes. And basically what carbon nanotubes look like is it's just a sheet of carbon. Sort of looks like a chicken wire, and where each of the corners actually has a carbon at the ends of it. Or if you think about a soccer ball, it sort of looks like a soccer ball that's sort of been stretched out at where you have carbon at each of the corners. The surfactant functional, both of the carbon nanotube projects have applications in solar energy. I actually have preliminary research results on the surfactant modification of carbon nanotubes. And what I've been able to do is to modify carbon nanotubes by using a surfactant, and it changes the electrical conductivity of the carbon nanotubes. I've gotten electrical conductivity somewhere below the electrical conductivity of silicon, but this is actually a mix of semiconducting and conducting carbon nanotubes. So it's possible to affect the electrical conductivity better than what I've been able to do. And then the possible application of this surfactant modified carbon nanotube is to make a second generation of the ITO backing that a lot of people use for their organic type of solar energy collecting systems. The second project is a chlorophyll modification, chlorophyll functionalization of a carbon nanotube. And if you sort of think about it, this is sort of a biomimetic method of making a solar energy collector, a second generation organic solar energy collector. And sort of if you think about it, what does chlorophyll do? Chlorophyll, the function of chlorophyll is to capture the energy from the sun and convert it to a chemical form. So the plant captures the energy from the sun and turns it into sugars. And this is really the way that almost all of the energy on the Earth originally started. Even petroleum is basically from the effect of the chlorophyll capturing of the energy from the sun and then converting it over a period of time to make petroleum products. So, if you just sort of think about it, just intuitively, it sounds like a really neat way of generating energy. My second research project is a photodimerization of thymine project. And this is a bioorganic approach to understanding the reaction implicated in skin cancer. What happens is in skin cancer, the sunlight hits DNA, and it causes this reaction, this 2+2 photodimerization reaction of your thymine, and it causes a kink, and then things happen, and then you get skin cancer. This is believed to be the mechanism for this reaction. And what I do in my project is I take a derivative of thymine. It's not attached to DNA, it's just a standalone molecule. Or you could link it and sort of simulate or model the photodimerization that you get in skin cancer. But what's nice about this project is it eliminates a lot of the variables that you have in real DNA. So in real DNA, there's this long chain of the rest of the DNA, and there are all sorts of effects as a result of the phosphates going in there and having an effect, and the sugars are flipping around, and there are all these other effects. But when you eliminate all these other effects by making a simple bioorganic model for this reaction, then you eliminate all of the variables. So in a way, it makes the understanding of the reaction much easier, and it also makes it a simple enough reaction that you can actually give the reaction to sophomore organic chemistry students, and they can actually make a contribution and actually make results out of this simple reaction that can be used to explain or understand the mechanism implicated in skin cancer. My third project is a synthetic methodology project, and in this project I'm looking at stereoselective synthetic methodology for working with this class of natural products. There's some 200 molecules in this class of natural products. They all have neurobiological effect, and I'm developing synthetic methodology to make potential pharmaceuticals for things like Alzheimer's disease and Parkinson's and things like that. All the neurobiological effect pharmaceuticals. The synthetic methodology involves organoaluminum catalysis and also a zwitterionic effect to control the stereoselectivity in this class of molecules. The fourth project that sort of isn't actually a chemistry research project, but is really is something that goes on in all of those research projects, is sort of an educational project. So what I'm doing is I'm working with primarily undergraduate students who have a very limited chemistry background. And it's not like I decided, I thought to myself, oh, I'll work with undergraduate students who have limited chemistry background. It's not that. What happened is I worked with the students that I could get access to, and it just turned out that there weren't that many chemistry majors that I could get access to, but I could get majors that were outside of chemistry, and they had kind of limited chemistry background. So I learned to work with them, and the idea is to I stumbled upon this method of teaching students to do chemistry research in a very short period of time, so that they can actually make research results with a very limited chemistry background. And the nice thing about this is that they enjoy doing the chemistry research. They get money from doing the chemistry research, and this helps them with the retention problem and doing better in their courses. It's a potential tool for recruiting students into chemistry and the sciences. But the idea is that I can get students to get chemistry research results with a very limited chemistry background, and I think it's something that could be very useful for and could be widely disseminated for a method of dealing with students who have a limited background in helping them to do chemistry research. So in summary, I have really 4 research projects. 3 of the research projects are very state-of-the-art research results that basically fall under the heading of sort of bioorganic materials with some synthetic methodology, and then the educational project of training students with limited chemistry background to do chemistry research. And I think this is really, I chose these projects because I think that they really have the potential of making a big difference in how things are going to get done in the future. Because petroleum-based energy is at one point, it is very soon in the near future, is going to be completely depleted. And then you really have to put your best minds and efforts into coming up with an alternative solution. And I think that the probably the easiest alternative solution is the solar energy option, and then the idea of understanding the reaction implicated in skin cancer, and developing synthetic methods for making pharmaceuticals. I think those are like really fabulously interesting things, and really can make a significant contribution to the way that you deal with disease. And then really the idea of affecting the way that you train students to do research. I think maybe that idea really has the potential to be used and widely disseminated and applied across the board. And I think maybe that's the most important thing that you can do, because then you're influencing what the next generation is going to do with their lives, and you're using the workforce of the next generation to actually make significant changes for how things are going to get done in the future.